No, I forgot who you said. Okay, students, we begin our unit on functions. We're going to try and make this unit as quick as possible. Last unit, I spent 6 days, 6 days on section 1.6, and that will not happen. We will try to move through quickly. We have 4 sections to cover. Hopefully, we can do that in about 9 days and be done with it, okay? So, what you need to do is start by identifying different characteristics of a function. We wrote these down previous hour, but a function, generally people identify x and y values. They think of inputs and outputs. They think of domain and range. Maybe think of a graph or coordinates or table. And finally, I think that a lot of people, when they hear the word function, they think of the vertical line test. Anybody remember what the vertical line test says? What does it say? If it crosses a graph more than once, then it's not a function. All right? Now, let's give a real example of what a function is, okay? So, Dylan and Chris both play on the soccer team, right, guys? Okay, so if I look in the box score one day after soccer, and I see that Dylan scored 4 goals and Chris scored 2, is that a possible box score to see that? Yeah. Is it also possible I could look in the box score and see that Dylan scored 0 and Chris scored 9? Yeah, it's unlikely that one player would score 9 in a game. Well, we could see that. I mean, if anybody could do it, it'd be Chris, right? Okay. Now, finally, what if I looked in the box score and I saw them both scored 0? Is that possible? Is it possible I could look in the box score and see that every player on the team scored 1 goal? Yes. But is it possible I look in the box score and I see that Dylan scored 1 and 3 in the same game? No. Why? Yeah, it's one or the other. We know that Dylan will have 1 output in terms of total number of goals for the game. Just 1. So the players are the domain or the inputs. The outputs is the number of goals. And so this will bring us to our definition of what a function is. You have to memorize this perfectly for the test, exactly as I write it. A function is a relation in which every element of the domain corresponds to exactly 1 element in the range. A function is a relation in which every element of the domain corresponds to exactly 1 element in the range. So, again, my domain elements are Dylan and Chris. My range elements are number of goals scored. They can both have the same range elements, but they both can have only 1 range element, okay? And we will talk more about that as time goes on. The deal is that if we have a function we identify by the notation f of x or g of x, the function name is the letter, and then the variable is in parentheses. And that way we can trust that if we put something in, we get out how many things? 1. You might say, well, come on. I mean, you don't ever worry about getting out more than 1. Yeah, you do. A circle, right? Circle doesn't satisfy the vertical line test. You would have a problem. In this situation, we just plug in 1 thing and we get out 1 result, f of -3. This means that the x value assumes a value of -3. So on the left side, if I write -3, on the right side, I have to replace the x with a -3. And I get -14. Easy peasy? Right. So we're going to evaluate all of these. F of 0 would be -5. And f of 2 is f of a, what would I do for f of a? Just put in an a for the x, 3a minus 5. Nope, it's done. F of a minus b, I replace x with a minus b. Now I have to distribute and see if I can combine any like terms. I get 3a minus 3b minus 5. Are there any like terms I can combine? No, so that's it. For b, why don't you come up with on your own f of negative 3, f of 2, f of 0, and f of a. We'll do the last one together, but take a minute here and come up with those. Okay, what do you got? F of negative 3? We get 9 minus a negative 6. So you should have 15. Careful for the negatives. F of 2, 0. 0 squared minus 2 times 0 is 0. F of 0, again 0. F of a should be a squared minus 2a. Good. So now we do f of a minus b. A minus b, quantity squared, minus 2 times a minus b. Notice how I insert parentheses around whatever I'm substituting in. That keeps me from making mistakes with my negatives. How do we square a minus b? Yep, FOIL, a minus b times a minus b, and I get a squared. Minus 2ab plus b squared. Good. I can't combine any like terms. Okay, we'll move on to C and D. C and D are a little bit different. It doesn't make them difficult, but they are different. These are what we call piecewise functions. And piecewise functions have different domains for different rules. So depending on what the x value is, we'll choose the rule. If the x value is less than 0, I'll choose the first one. If the x value is greater than or equal to 0, I will choose the second one. Same thing over here. This one has 3 different pieces to it. And you can have as many pieces as you want. Are these real functions? Yes. Do they come up in later times? Yes. You do have to learn how to graph them later on in this unit. They come up in calculus a lot. So this is something we want to be able to work with as piecewise functions. So I'm going to evaluate just the first 3, f of negative 3, f of 0, and f of 2. What is f of negative 3? What do? Do I plug that into the first one or the second one? Why do I plug it into the second one? Negative 3 is less than 0, so therefore I plug it into the first one. Okay, so I'm going to look at the value of the x. Because the x is less than 0, I will plug it into the first one. I get 2 times negative 3 minus 1, which is negative 7. Where do I plug in 0? For the first one or the second one? Why? Because it is equal to 0. That one's easy. It's just 0. And where do I plug in 2? Second one. And I get negative 1/2 times 2 squared minus 3 over 2 times 2. So negative 1/2 times 4 minus, the 2's will cancel, I get 3. Negative 2 minus 3 is negative 5. Questions? Yes. Because we don't know if a is less than 0 or greater or equal than 0, then we don't know. So I'm going to leave those off of this one. We would say we don't know. So. All right, -3. Which one do I plug it into? The first, second, or third? Which one? The first one, because -3 is less than -1. So I have 2 times the cubed root of, what's 5 minus -3? 8. The cubed root of 8 is, times 2 is 4. Where do I plug 0 into? The first, second, or third? The second. What is always the value of the second function? It's always 18. Doesn't matter what the x value is. The output is always 18. It's a horizontal line that goes through 18. That's what it is. And where do I plug in the third one? For the last one, 9 times 2 minus 2 is 16. We good there? Okay. Flip it over. We'd like to get through the next 4, but we might run out of time. So we begin. We got out of here at 1. Is that correct? Okay, so we've got 10 minutes. We'll for sure get done with the first 2. F of a plus h minus f of a all over h. I want to find that for this. So what I'm going to do first is I'm going to identify f of a plus h. That means instead of using x, what do I plug in for x? A plus h. So I have a plus h quantity squared. That's what I get when I plug in a plus h. Correct? Anybody confused about how I came up with that? F of a, what do I plug in for x now? When I plug in a, I get super duper. Now, I will write the rule. The rule says I'm supposed to find this, whatever that is. Well, f of a plus h is a plus h quantity squared. Minus, what is f of a? A squared. All over h. Here's what will happen. Look up on the board here. You see all these things that cancel? It's awesome. A lot of things cancel. It just works out that way. It's really nice. So we're going to see some things cancel here. In fact, enough things are going to cancel such that the h will divide off. So let's see what happens here. Let's square out that a plus h. What do you get? If the h will divide off from the denominator, that means that everything in the numerator that doesn't have an h should cancel, right? Well, let's look at the things that don't have an h. Does the a squared cancel? Yeah. And that way, everything else has an h. So can I factor an h out of the top? And I'm left with h times 2a plus h all over h. What can I do now? Divide the h's off, cancel, and I get 2a plus h. That is the reduction that happens. So I have 2ah plus h squared. You take an h out of that, factor an h out, we get this. 2ah, if I take the h out, I'm left with 2a. H squared, if I take an h out, I'm left with h. Okay. All right, the next one. We have g of x. G of a plus h. What is it? Good. 2 times the quantity a plus h minus 3. What's g of a? I'm now going to write the rule. You might say, well, I don't have an f. But it doesn't matter. We can do g of a plus h minus g of a all over h, okay? So we're just going to roll with it. Doesn't matter if the letters don't match up, okay? We can do the same type of thing. So I have g of a plus h, which is 2 times a plus h minus 3 minus, I have to distribute that negative, right? So I have parentheses 2a minus 3. If you didn't write it with parentheses, then you have to write minus 2a plus 3. It's the number one mistake that gets made in this type of a problem. Divided by h. Let's distribute the top. What do we get? 2a plus 2h minus 3 minus 2a plus 3 all over h. What happens? 2a's cancel, the 3's cancel, and they should because they don't have an h. If it doesn't work out like that, you did something wrong. It's amazing. It's part of the beauty of calculus. It allows us to find slope down at 2 points, but at 1 point. And it works out this way that they will always cancel. And so you have 2h over h, which is 2. All right, we won't get to k, but we are going to do h, all right? And then during second hour or third hour, we did get to do that one, but this is a little bit larger class, and so handing out papers and stuff takes longer. All right, we do h of x. What is h of a plus h? Good. What is h of a? Yep. So I have to subtract the 2 and divide by h. So I have 5 times a plus h minus a plus h quantity squared minus the quantity 5a minus a squared all over h. Now, before you, yeah, we're going to square it. It's going to get a little bit bigger. Before you get angry about that, just look at the board and realize, okay, life could be worse. Okay. It's all about perception. 5 times a, 5a, 5h, minus 2ah, minus 5a, plus a squared, over h. Awesome sauce. What cancels? 5a and negative 5a. Done and done. Negative a squared, positive a squared, done and done. Does everything else have an h? Yeah. H times 5 minus 2a minus h over h. H's cancel. 5 minus 2a minus h. Not too bad, huh? One of those problems you won't be able to do yet because it involves a fraction. But folks, we got to put the pedal to the metal. Math's really got to be a priority here next couple weeks. We're gonna be moving quickly, okay? And so you got to stay on top of your homework. Just as you saw, you had some new material today. You are going to get to some new material pieces. Yes, you'll see some review pieces, as you will throughout all of college algebra, but there's going to be some new stuff from time to time now. Yep. Take home the book. Come to conferences, ask me questions. I've had people do that before. Had nobody at conferences. And all of a sudden, somebody will sit down with their book. They're like, "Can we do some math?" Heck yeah. All right.